Okay, we are starting a new chapter, chapter 4, and section 1 is solving systems of equations by graphing. So let's go jump to the first question. It says determine if the point 1, 0 is a solution to the system. And remember that a system is going to be two equations, and that solution has to work. In other words, it has to be true in both equations. So for the first equation, 6x plus 3y equals 6, we're going to plug in 1 for x and 0 for y. 6 times 1 plus 3 times 0. So that's 6 plus 0, which is 6. So yes, it works in the first equation. Now let's go plug it into 2x plus y equals 2. So 2 times 1 plus 0, 2 plus 0 is 2. So yes, it works in both equations. So that point is a solution to the system of equations. Question 2. Determine if the point 3, 1/2 is a solution to this system. Okay, remember the 3 is going to be our x and the 1/2 is going to be our y. We need to plug those in to both equations to see if we get a true statement or not. So the first equation is 3x plus 6y equals 12. So plugging in 3 for x and 1/2 for y, I'm going to go do this on my calculator. So 3 times 3 plus 6 times 1/2 gives me 12. So it works on the first equation. How about the second equation? 2x minus 2y equals 5. So 2 times 3 minus 2 times 1/2. Let's go see what that is. 2 times 3 minus 2 times 1/2. I get 5. Yep. So 5 equals 5. Yep. So that point is a solution to the system of equations. Question 3. Match the graph of the system of equations with the appropriate description of the solution. Okay. You have two lines graphed, and the solution is where they intersect. So it looks like the red one and the blue one intersect right here at the point 0, 3. So there's one solution, and it's at 0, 3. Question 4. Graph each system of equations. And there are 3 systems we're going to graph. So for the first one, both equations are the same. You have y equals 2x minus 3 and y equals 2x minus 3. If you were to plot it on your calculator, 2x minus 3, and the red one is 2x minus 3, hit graph. There's the blue one, there's the red one. The red one is on top of the blue one because they are the same equations. So to graph them by hand, y equals 2x minus 3. The y-intercept is negative 3. And then my slope is 2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. There's my line. Now for the red line, y equals 2x minus 3. Y-intercept is negative 3. My slope is 2, so up 2, right 1. And like we saw, it was the exact same line. So there will be infinitely many solutions to that system. All right, second system. Y equals negative 2x minus 4. Y equals negative 2x plus 2. So let's graph y equals negative 2x minus 4 in blue. Y-intercept is negative 4. The slope is negative 2. So I'm going to choose to go up 2 and left 1. Up 2, left 1. Up 2, left 1. Up 2, left 1. Here's my blue line. Now for the red line, y equals negative 2x plus 2. My y-intercept is 2. My slope is negative 2. So up 2, left 1. Up 2, left 1. Up 2, left 1. Here's my red line. They never intersect, so there is no solution to that system of equations. Last one for this question. In blue, I'm going to graph y equals 3x plus 3. And then in red, I'm going to graph y equals negative x minus 1. Y equals 3x plus 3. The y-intercept is 3, and my slope is 3. So I'm going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Or I could go down 1, 2, 3 and left 1. Down 3, left 1. Down 3, left 1. Here's my line. Oops. All right. Now for the red line. Y equals negative x minus 1. The y-intercept is negative 1. And my slope, if you need to see that as negative 1x minus 1, so you see the slope is negative 1, I'm going to go up 1, left 1. Up 1, left 1. Up 1, left 1. There's my red line. My solution, there's one solution, and it is negative 1 comma 0. Question 5. Determine which system of equations, A, B, or C, makes the statement true. Okay, the statement is that the lines coincide. That means that they are the same line. Okay, so that means that your y-intercept and your slope have to be the same. These have different y-intercepts. It can't be A. These have different y-intercepts. It can't be B. These have the same y-intercept. Oh, and look, and the same slope. The slope is negative 1. So C is a system where the lines coincide. Okay, for number 6, solve the system by graphing. For systems that do not have one unique solution, also state the number of solutions and whether the system is inconsistent or if the equations are dependent. I'm going to go do a little detour here and do 3 different types of situations. You can have 3 different types of solutions to a system of linear equations. If your equations do indeed intersect, hold on, so they intersect like those 2 lines do, you would have one solution. These equations, it would be a consistent system with independent equations. So a consistent system with independent equations. If you had a system that had parallel lines, there would be no solution, and we would say that it was an inconsistent system. Inconsistent system. If we had a system where the lines they coincided, so they were the same line, we would say that that system has infinitely many solutions. This is a consistent system with dependent equations. So notice that the consistent systems, this one and this one, those have solutions. If the system does not have a solution, we say it's an inconsistent system. Now, the difference between the two consistent systems, if the equations are independent, then there's one solution. If the equations are dependent, in other words, they depend on each other, they have to be the same, then there are infinitely many solutions. All right, so let's go graph these two equations and see which of the three possibilities that we get. All right, for the blue, y equals negative 2x plus 1. And for the red, let's go graph y equals negative x. Y equals negative 2x plus 1. The y-intercept is 1. The slope is negative 2. So I'm going to go up 2, left 1. Up 2, left 1. Or I could have gone down 2 and right 1. Down 2, right 1. And that's because the slope is negative 2 over 1. So here's that line. And my red line, my y-intercept is 0, but my slope is negative 1. So I'm going to go up 1, left 1, up 1, left 1, or I could go down 1, right 1. So my red line looks like that. I have those lines intersect right here. So I have one solution at 1, negative 1. So let's see what they say. Part 2. The solution has one solution, and the solution is 1, negative 1. Question 7. Solve the system by graphing. We have 2x plus y equals 4 and x equals 3. Okay, for the 2x plus y equals 4, I'm going to go put that in slope-intercept form, y equals mx plus b, because that's easier for me to graph. I need to subtract 2x from both sides, and I get y equals, write the x part first, negative 2x plus 4. So to graph that, y-intercept is 4, and the slope is negative 2. So negative 2 over 1. I can go up 2 and left 1, or I can go down 2 and right 1. Okay, there's my line. Now for my red equation, x equals 3, x is always 3. Doesn't matter what the y's are, x is always 3. So there's that red line. Those two lines intersect in one point, and that point is at 3, negative 2. So I have one unique solution, and that solution occurs at the point 3, negative 2. Question 8. Solve the system by graphing. Okay, our first equation is 3x plus y equals negative 2. I'm going to go put it in slope-intercept form. So I need to subtract 3x from both sides, and I get y equals negative 3x minus 2. The y-intercept is negative 2, and my slope is negative 3 over 1. So I'm going to go up 3, left 1, up 3, left 1. Or I could have gone down 3, right 1. There's my blue line. For my red line, negative 9x minus 3y equals 6. I need to add 9x to both sides first. I get negative 3y equals 9x plus 6. Now I need to divide everything by negative 3. I get y equals 9 over negative 3 is negative 3x. 6 over negative 3 is negative 2. My y-intercept is negative 2, and my slope is negative 3. So my slope is negative 3 over 1. Oh, look, up 3, left 1. It's the same line. Since they're on top of each other, there are infinitely many solutions. Let's go look at what we have. The system has infinitely many solutions. The solution set is the set of all xy such that, I don't know what it's wanting, but I'm assuming it wants y equals negative 3x minus 2. So the equations are dependent. Question 9. Solve the system by graphing. Okay, my blue equation is going to be x minus y equals 3. I need to subtract x from both sides. Negative y equals negative x plus 3. Then divide everything by negative 1. I get y equals x minus 3. My y-intercept is negative 3, and my slope is the number 1 that's out front of the x. There's a 1x, right? So I'm going to go up 1 over 1, up 1, right 1, up 1, right 1, or down 1, left 1. So here's my blue line. Oop. For my red line, I just need to divide everything by 3 to get y by itself. Y equals 3 over 3 is 1, so 1x, plus 8/3. My y-intercept is 8/3, which is 2.667. So 2.67 about right there. And my slope is also 1. These two lines have the same slope, which means that they are parallel lines, which means that they will never intersect. There is no solution. So there is no solution. It's an inconsistent system. Last one. Explain why the ordered pair negative 6, 2 cannot be a solution to the system of equations. Okay, where is this point? Negative 6, 2. Regardless of what the scale is, it would be up in this quadrant. It's quadrant 2. But the solution to this system is down here in the third quadrant. So let's go see what the answer choices are. Okay, the point of intersection is above or below the x-axis. So where's the point of intersection? Right here? It's below the x-axis. Okay, let's see what else. The point of intersection is below the x-axis, and blank have a blank y-coordinate. It cannot have a positive y-coordinate. Because down here, the y value would have to be negative, right? So this point cannot have a positive y-coordinate. And that's it for this homework set.